Let's just make sure it's recording. Let me see. Yep, it's good to go. All right, so as you see, we're doing section 2.3, and it's lines. Okay, that seems pretty general. We're going to get a lot more specific about it, but that's the general title of this section. The first thing we're going to do is talk about a word. You've seen this word before, I'm sure, and it's slope. Do you remember doing stuff like that in your algebra classes? You probably did it in Algebra 1, Geometry, and Algebra 2 as well, didn't you? Yeah, sure you did. Do you remember what letter we use to signify the slope? We use one letter. What is it? M. We use M, the letter M. Why in the world do they use M? I looked it up one time, believe it or not, because I didn't have much to do. So I looked it up, and I should have looked it up before I came in here. They're not really sure where the M came from. It goes way, way back. But I think if I'm right, you can look this up yourself, but it's supposed to be Latin, and it has something to do with mountains, right? The M is for mountains, because what do mountains have? Mountains have what? They have slopes, okay? They go up and they go down, okay? And so if you think of it, I don't think it's 100% mountains, but that's how I like to think of it, okay? So when I think of slope, think of mountains. Of course, I like to hike up and down mountains. Actually, I'd rather get to the top and just walk straight across, tell you the truth, instead of going up and down, because that's the hard part. But anyway, I like to see the mountains, and they have slopes. So you can kind of think of it that way, even though it's not 100%. It doesn't 100% stand for a mountain, but it's kind of a way to remember it. So we have a little thing to remember. Okay, I'm not even going to get into the equation just yet. In a few minutes we will. There's two words. There's something over something. Do you remember what that is? Rise over run. Very good. Cam, you got that right? All right, so it's rise over run. That's what the slope is. And that's really important right there, is to understand that the slope is the rise over the run. So what is the rise? Well, the rise is how much you go up and down. Which axis, the x and y axis, which axis goes up and down? The y-axis. That's the rise, okay? So the rise goes up and down. That's along the y-axis. The run is which axis? It's the x-axis, okay? So that's your run. It's pretty easy to remember, isn't it? The rise goes up and down. The run goes across like this, all right? People watching the video won't be able to see it, but my hand is going horizontal, all right? So that's the rise and that's the run. So for instance, if I'm just going to draw a line right there. We'll put little arrows because it is a line. Keeps on going like this. So if I take any 2 points, and that's what's pretty cool about this slope, it doesn't matter what 2 points. I can take any 2 points on the line, and if I do this, let's do this in a different color just so it stands out a little bit. Okay, watch. If I take this, oh, it lines up perfect right there. That's nice. To that, and then to that. There we go. So this up and down part right here is called our what? Our rise. Okay, that's the up and down. That's how far we go up and down. And what is the one that goes across like this? That's the run. All right, so it's rise over run. That's how you find the slope. The slope is basically how steep your line is. It's basically what it is, okay? The higher your rise, the steeper your slope. You got it? Okay, the steeper the line's going to be. You could take any points. Let's do this in another color. Let's just hit the blue. Watch. Let's say I took this point and this point. Now, I'm not even telling you any points on this, okay, like what the coordinates of the points are. But if I take this, drop it down to there, take this, take it across to there. It's supposed to be horizontal and vertical. It was off a little bit, but that's okay. And if I took this rise and this run, guess what's going to be true about the blue one? If I take this rise over this run, now they represent numbers, right? The rise is how far. Okay, if I take the distance of the blue rise and I take the distance of the blue run and I divide them, I put the rise over the run, guess what is going to happen if I do the same thing with the red one? So watch, if I take the red rise over run, now I didn't put any numbers in here, so you don't know exactly what the numbers are, but what do you think might be true about the blue one and the red one right here? They're exactly the same because they're 2 points on the same line. Everybody got it? what I said earlier, it doesn't matter which 2 points you choose. I could pick any 2 points of that line right there, and if I make a vertical and make a horizontal to connect those 2 points, the rise over the run is going to be the exact same thing. It doesn't matter which 2 points that you choose. Does that make sense? All right, so that's kind of interesting. I think it is. Okay, it's basically proportional, all right? Because is it any more steep from this blue one to this blue one as it is from this red one to this red one? No, it's no more steep. You're still on that same slope, right? It doesn't matter if you're higher up the mountain or lower on the mountain. It's just as steep to get from one point to the other. With me? Okay. So that's a little bit about slope. Now, let's do a little bit more with this. Let's talk about positive slopes, negative slopes, and that kind of stuff. All right, so let's do one. Oops, let's keep this white. Oh, right there. All right, so here's a line right here, and let's take a look at this. So rise over run. So let's just connect these. I'll just connect them in white. Doesn't make any difference. Okay, that's pretty good right there and right there. Pretend that's horizontal. It was off a little bit, but you get the idea. Okay, so there's our rise and there's our run. So we could go from one point to the other. We could go from the top one to the bottom one, or we could go from the bottom one to the top one. It doesn't matter how we go. Okay, I could have taken my rise up like this and the run over like that. It wouldn't have made any difference. All right, I just decided to do it on this side of the line. It doesn't make any difference. But what I want you to see is this. So rise over run. So rise over run. So if I start at the top and I go down, I'm going down. So what kind of I can't think of it. Is it negative or positive? What direction? Okay, if I go down, that's negative, isn't it? Okay, so I'm just going to put a negative right there. So now I'm right here. So I did a negative rise, and now what do I have to do to get to that point? I have to go in which direction? To the left, which is negative. So what's negative over negative? It's a positive. So this line right here is a positive slope. You got it? So if I'm reading from left to right, which we normally do, right? Unless I guess you're Chinese. We don't have any Chinese people in here doing. Okay, you have to ask one of your friends that are from China here. I don't think they do it anymore. I think they used to. I think like the old Chinese, I think they read from right to left. And they might have gone from bottom to top. I'm not really sure. Ask somebody, okay? I should have found that out too. But anyway, we don't read right to left. We read left to right. And so which direction is this line going? If you're looking at it from left to right, which direction is it going? It's going up, isn't it? Okay, up is what? Positive. Make sense? So let's do another one like this. And put a little line right here. Pick any 2 points. Because does it matter? Does it matter what 2 points you pick on the line? No, we just discussed that. Okay, so I could pick any 2 points on the line, and I'm going to take it from here. Try to keep that. There we go, right there. And then I'm going to go to here. Okay, and you got your rise here, and you got your run right here. So let's go from one point to the other. It doesn't matter if you go up and over. It doesn't matter if you go down and over this way. All right. For some reason, I just did it like this. So let's do rise over run again. So the rise over the run, if I start from here and I got to get to this point, I'm going to rise in which direction? I'm going to rise negative again, aren't I? Okay. But now, look where I am. I'm right here, aren't I? And I got to get to this point. Which direction am I going to go? I'm going to go positive, going to go to the right. So what is a negative divided by a positive? It's a negative. So this is a positive. Oh, my handwriting's terrible. And this is a negative slope. All right? So you got a positive slope and you got a negative slope. Again, if I'm going from left to right, which way am I going on this hill? Going down the hill, aren't I? From left to right, if you look at it from left to right, okay, I'm right here. This is me. Boom, 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 boom. That's me. With a big fat belly right there, okay? And I'm going what? Down the hill, okay? Right here, I'll put a car. All right, there's my cool car, my little minivan. All right, and so now I'm going what? Going up the hill. That's positive. You with me? All right, so you know positive, you know negative. What if, I might be getting a little bit ahead of myself, but let's do this. Let's draw a line like this. What kind of line do we call this? Straight up and down. It's a vertical line. Okay, vertical, horizontal, right? This is a vertical line. Okay, what if I put 2 points right here? One right here and one right here. Let's do rise over run. Okay, we'll call it point A and point B. All right, so you see it. How far do I rise from here to here? Well, whatever. Okay, it's negative, positive. It really doesn't make any difference because watch what's going to happen. So it's got a certain rise to it, a certain distance. Okay, we'll just call it y. Is that all right? Now, if I go from here, what is my rise to get to B? I got to go down, right, to B. So I go a certain direction on the y-axis. I go down. You with me? How far over, left and right, do I have to go to get to B? 0. I'm already there, aren't I? I don't have to move left or right to get to B. I'm already there. So I'm going to put a 0 right there. What happens? What happens if you take a number, any number, and divide it by 0? We've talked about this in this class before. Who's got a calculator? Put in any number. I don't care. Who's got a calculator? It says error on the calculator. That's right. Okay? And we call it undefined. So the slope of a vertical line is undefined because you're dividing by 0. It means it doesn't exist. Here's an example that I always give. I used to do a little bit of skiing when I could afford it, maybe once a year, maybe once every couple years. It's been a long time since I've been skiing. I did not bring my dog skiing, no. I go by myself. So let's say here I am again. Boom, boom. There's my whatever. I can't even draw. That's how bad of an artist I am. I can't even draw. A sideways stick person. How am I going to do that? I don't know. So I have been skydiving, okay? But luckily I have a pair. Yeah, I have. So that's supposed to be me, all right? And this is a hill, right? As soon as I step off, what's going to happen? Boom, boom, boom. I'm going to be a mess, aren't I? Okay? What am I going to look like? If I'm on top of a big old mountain or on top of a building, I'm on top of the Empire State Building, right? And I jump off. I'm going to go vertical, as long as the wind's not blowing. Okay, I'm going vertical. And what's going to be left of me? There's going to be nothing left of me, okay? I'm going to be what? I'm going to be undefined. They're not going to be able to tell who I was, probably, okay? All right, so I'm going to be undefined. You with me on that? Okay, so that's how I think. That's my example every year I teach this, okay, of me falling off a building. I'm going to be what? Undefined, because it's vertical, okay? It's not really a slope. Would you ever go skiing? You could go to a quadruple black diamonds. Anybody been skiing before? The black diamonds are the tough ones, right? Okay, if you go to the black diamonds, they're the hardest ones. They have like a double black, a triple black diamond. I don't even know if they have triple. I don't know. But let's say you go to a quadruple black diamond. It's still going to have a little bit of a slant to it, isn't it? Okay, there's no way in the world that you're going to be on top and they're going to have you go straight down, because that is not a slope. That does not exist on a ski. Now, I've gone to mountains where I've looked over and it's completely straight down. I've rappelled. Did I ever tell you that story? I rappelled. I was in ROTC. Ever hear of ROTC? In college. Thought I was going to join the Marines and all that kind of stuff. I had a guy that I met in college, and he was in the Marines. He had this uniform. It looked so cool, and he had this cool haircut. That's probably why I have this haircut right now. That's as close as I'm going to get to the Marines. But anyway, I was going to join the Marines. I thought I'll join ROTC, see what it's like, and we went out to Virginia Military Institute, VMI, and we did rappelling. So at first, we went down a slope that was kind of like that, okay? Wasn't that big of a deal. Okay, didn't have much rise compared to the run. Follow me on that? Okay, so it wasn't much of a slope. It was pretty easy. We put ropes on and we tied it all up. It wasn't even a harness. It was just a straight rope, but they showed you how to make some kind of a saddle. They called it Swiss saddle. I can't remember. It was a long time ago. So that was pretty simple. Then they got us to the top of this thing right here. Okay, And there I was. Let me see, put a line. Here we go. Okay, so, all right, so I was on this little ledge, right? And so I'm straight up and down, right? They got me hooked onto ropes and stuff, and they're like, okay, let a little bit out. I'm like, okay. I'm like this. And I swear I was completely horizontal. I was completely perpendicular to the mountain, and it was straight down. It was just, and at the bottom were these big, huge boulders. It's, sharp boulders too. Not that it would make any difference if I would have fallen on a round boulder or a sharp boulder. It wouldn't make any difference. But anyway, I know I was perpendicular. My feet were against the rock side. I was looking straight up to the sky, and this guy's like, let out a little bit more, a little bit more. I'm thinking, what? I'm already perpendicular, and I've seen other people do it. And so I let more, and then all of a sudden, guess what happened? My head is now here, and my feet are like this. Whoa, I'm like that. I'm hanging by a rope, all right? I'm literally straight up and down. My back is against the wall. My feet are straight up, and they're freaking out. I could hear them. I mean, they're right above me, right? They're freaking out. These like, I don't know, Rangers, Army Ranger guys. They're like, don't move, don't move, don't move. I was like, oh, so embarrassed. And then when they start yelling, all the other people came around. So I just see one guy yelling, right? Don't move, don't move. And then all of a sudden, boom, like 20 people come to the edge and are looking over to see what's going to happen. I'm like, this is so embarrassing, right? I wasn't even scared. I was more embarrassed than anything. I was like, there's no way I'm going to have those guys come down and rescue me, right? And so I kind of got my feet against the side right here, and I kind of push off. I'm swaying. Oh, come on, pen. Don't fail me now. Let's try this again. All right. And I'm swaying back and forth like this, and finally I get where I'm perpendicular, and then I went boom, boom, right down to the bottom of it. I probably went faster than anybody else. And the dude down the bottom, he's holding the rope, and he's like, well, you had a little rough start, but man, you got down here faster than anybody else did. I'm like, yeah, man, I was so embarrassed. So that's my rappelling story. So there you go. All right. So I always save that story for talking about slope and vertical slope. All right. So I've never been rappelling since then, but I wasn't really that scared, but I just, I don't know. I was just more embarrassed than anything. I just didn't want to mess up. But all right, what were you saying, Kylie? Yes, go ahead. What if you had a slope like this? Let's talk about the rise and run over this thing. So let's say you had a point here and a point here. Now that's quite a bit of a different one than the rappelling mountain that I went down, isn't it? All right. So for instance, if you go skiing, let's go skiing again. Okay. If you go skiing, what would you call this? You call this the bunny slope, wouldn't you? All right. Basically, it's not even a slope. It's not even the bunny slope. It's like where you go to get to the bunny slope. It's just flat, completely flat. All right. So what kind of slope is that? Well, let's do the rise over the run. So to get from point A to point B, how far do you rise to get from A to B? You don't go anywhere up and down, do you? All I do is go across. All I do is run. So I go 0 rise and whatever the run is, we'll just call it x. What's 0 divided by any number, except for 0? What's 0 divided by any number? It's 0. So what kind of slope is a horizontal line? It's a 0 slope. There's a big difference between undefined slope and 0 slope. On right here, I have 0 chance of getting hurt unless maybe I just fall over and hit my head on somebody else's ski or something like that. I don't know, okay? But this is 0 slope. If I just stand there, how fast am I going to go? I'm going to go 0, aren't I? Unless somebody pushes me or something like that, okay? Unless I push off. I'm going to go 0. So this is 0 slope. This is what? Undefined, all right? It doesn't exist. You will not see a slope like this to go down when you're skiing. You with me on that? Okay, let's keep going. Let's do one more little thing here. Where's my line button? There it is. Let's draw a little x and y axis. And we're going to come up with a little formula to find the slope. They call it a definition. So we'll call it a definition, I guess. Let's change colors with the line. And I don't know, it doesn't matter. Let's just make it look like this. Put a line on it right here. So let's pick 2 points. Again, it doesn't matter what 2 points you pick because the slope's going to be the same no matter what 2 points that you pick. All right. But what I want to do is this. If I drop this down, how far over is this point? Like, what's the coordinates of this? Well, if I come over here, this is on the x-axis. I'm not going to put actual numbers right here. I'm just going to put an x1. Is that all right? So to get to this point, I go over x1 and I go up. What do you think I'm going to go up? Well, I went over x1, so I'm going to go up what? y1. Very good. Okay. What about the second point? I'm going to come let's see where this drops down to about right here, it looks like. Just eyeballing it. Call this x2. All right. So how far up do I go then? That would be about right here. I go up what? y2. All right. You with me? All right. So let's do this. Let's draw another line. Let's put a different color. And what I'm going to do is do my rise and run. All right. Oops. That always, every time I lift up my pen, it always goes a little bit off. It's good enough for us. All right. So let's check this out. What is this distance right here? For instance, what if this was a 10 and this was a 2? How long would that little line, horizontal line, be? Come on, help me out. It'd be 8, right. If this was 10 and this was 2, I go 10 minus 2, and the length of that would be 8, wouldn't it? But I don't know it's a 10 and a 2. I know it's an x2 and an x1, so how did I get 8 out of 10 and 2? I took x2 what? Anybody here? Minus x1. All right. I'll answer for you. Is that all right? Guess it is, since nobody else is answering me. All right. You guys are killing me. All right. Is it that bad? So what about this? If I go from here to here, what if this was 7 and this was 5? How would I find the length of this? I'd go what? 7 minus 5, which would be 2, right? But I don't know it's 7 and 5. I just made that up. But how would I find it if I knew those two numbers? I would go y2, what? Minus y1. You with me? So what is our rise? Remember, our slope is rise over run. So what is the rise here? It's the distance you go up and down. How far do we go up and down? y2 minus y1. That's right. y2 minus y1. Trey, you getting all this? Good. How far did we run? How far did we run from here to here? What is the length of this part right here? x2 minus x1. Very good. So it's x2 minus x1. Right there, we have our formula for the slope. That's what you need to memorize. All right? Showed you how to get to it. Basically, I showed you why it was what it was, but now you just have to memorize it. So how do you find the slope of something? It's the y2 minus y1, or something that they say a lot. Looks like a triangle, but it's a delta. You ever see the Greek letters? Okay, that's a delta. So we go delta y over delta x, or the delta represents in math, it means the change in something. So this is the change in y over the change in x. Anybody taking physics in here? No physics? You've probably learned change in, right? Change in velocity is acceleration and all that kind of stuff. Yeah, good. So it's the change in y over the change in x. That's delta. So I just threw that in there because you'll see that quite a bit later on. All right. But this is what you need to know. y2 minus y1 over x2 minus x1. All right, let's keep going. Let's do an example. So example 1. All that, we're finally at an example. All right. So what we're going to do is we're going to find the slope. I'm not going to write out the whole instructions. It's in the book if you want to see it. But it says find the slope of a line containing these 2 points. So find the slope of a line that contains these 2 points. If I wanted to, I could put a graph here, plot the 2 points, and then count on the graph my rise and my run. I could do that, but that's too much. All right. What do you kids say? That's extra, right? You don't need to do that. So what we can do is we know our formula. We don't have to graph it and figure it out. We can just use our formula. What is it? It's a change in y over the change in x, or just subtract the y's over and you subtract the x's. That's the rise over the run, isn't it? Okay? Make sure you put the y's on the top. A lot of people put the x's on the top because they just think x comes first. All right? But the y has to go on the top. Why does it go on top? WHY does it go on top? Because it's the rise. It's the rise over the run. Okay? Yes. All right, so let's put the numbers in. Let's see what we get. So y2 minus y1. Which one's, this is our x1, this is our y1, this is our x2, this is our y2. This is our first point, this is our second point. And to tell you the truth, we're going to find out here in a second, it really doesn't, everybody listen, it really doesn't matter what order you subtract the y's. It says y2 minus y1. I could go y1 minus y2 if I wanted to, as long as you do the same thing on the x's. Did you hear what I just said? It's really important. Tap Peyton so she's paying attention. She's probably thinking of the lesson she's going to teach in my next class. She's my special speaker in my next class. So she is. I'm not lying. So y2 minus y1. You could go y1 minus y2, but what would you have to do on the bottom? You'd have to go what? x1 minus x2. All right? So we'll do it both ways just to show you it doesn't matter. So let's do it. y2 minus y1. What's my y2? It's negative 3. Minus my y1, which is 2. We'll figure that out in a second. Let's do the x's. Take the x2, 5, and then minus the x1, which is a 1. This is negative 5 over 4. And that's my slope right there. Okay? That's how steep it is. If you go down 5 and to the right 4, that's how steep that line is. You could find it the other way. Instead of y2 minus y1, let's subtract the y's in a different order. Okay, I could go 2 minus, is it just 2 minus 3? Nope, it's 2 minus negative 3. It's supposed to be a negative right there. It's a little curly Q. Let's do the x's. 1 minus 5. Let's see what we get. What's 2 minus a negative 3? It's a positive 5. Over 1 minus 5 is negative 4. Is negative 5 fourths the same as positive 5 over negative 4? It is. It's exactly the same. Or you could write it like this. You could put the negative right in between the little fraction sign. All three of these mean exactly the same thing. Okay? So I would accept any of those right there. So that's how you find the slope. Pretty easy, huh? When do we get out of here? I ask that every day, don't I? 10 minutes? All right, I can do this in 10 minutes. Let's see what we got. Example 2. I'm going to put this thing here now. So we're finally going to use this. Oh, come on. Grab it. There we go. There we go. Put it right there. All right, here's what they're asking you to do. They're finding the slopes between these 4 points. Okay? And they're going to put 4 lines. So L1 means line 1. All right, and they give you a point P, which is at 2, 3. In fact, every single one of these lines is going to have 2, 3 as one of its points. But then they give you a second line, or a second point, I should say, Q1, and this one's going to be different. The Q's are going to be different. So negative 1, negative 2. So let's just write them all out. L4, boom, boom, boom. And let's see. The P is always 2, 3. Let's just put that with all of these. I'm trying to go as fast as I can here. And then we got a Q2, we got a Q3, and we got a Q4. Now these are going to be different. So we get 4 different lines. They're all going to go through the same point. So they all intersect each other at 2, 3. But they all are different lines. So Q2 is 3, negative 1. This one is 5, 3. And this one is 2, 5. Okay? What I want to do is I want to find the slope of all these lines. So let's do, I really didn't give myself a lot of room here. That's all right. I'll just do it down here. We'll do the math kind of easy. So let's find the slope of the first one. I'll put M1, okay? So how do you find the slope? You subtract the y's and you put them on top. It doesn't matter what order you subtract them. Let's just go the first one minus the second one. So 3 minus negative 2, and then the x's is 2 minus negative 1. What is that slope? That's 5 over 3. So that's the slope of line 1. Everybody with me on that one? All right, so let's draw it. We'll put all these in different colors. Make it nice and pretty. So what are my points? 2, 3, 2, 1, 2, 3. And then the other one is -1, -2. And if I connect these lines like this, and then let's stretch this out a little bit further, about like that. That's good enough. All right, there we go. So that's that line. I could take any 2 points on here and find the rise over the run. It's going to be 5 over 3. So that's one line. Everybody with me? All right, let's do another one. Let's do the second one. Tell you what, let's just, for the sake of room, I'm just going to get rid of that. So let's go M2. Find the slope of this one. So again, we subtract the y's. So it's 3. This is good practice to find the slope. 3 minus -y, and then 2 minus 3. What do we get? 4 over -1. What's 4 over -1? It's just -4, okay? So that would be my slope. Let's plot the thing. Let's go blue on this one. So let's plot it. So the second one is 2, 3, so it still goes right through here, and 3, -1. So 1, 2, 3, -1 right there. And let's draw the line. Again, it goes through 2, 3, so it goes right through that point right there. And right there. Okay, so there's my graph. All right, and it has a slope of -4. Look, it's negative. Which way is it going? It's going down. From left to right, it's going down. What's the red one doing? It's going up because it's positive. Do you see that? That's pretty important. All right, let's do the third line. So L3. So we go the slope of line 3. So how do we do that again? Subtract the y's. Oh, look what we're going to get this time. It's a little different. So it's 3 minus 3 over 2 minus 5. What's 3 over 3? 0. So what kind of line is this going to look like? It's going to have a slope of 0. What do you think this line is going to look like? It's a 0 slope. Think of skiing. If it goes 0, it's kind of a line. It's horizontal. It's horizontal, okay? It should be, right? Let's plot it, see if it actually is. Let's go green. So what are my points? 2, 3, right there where we always are, and then 5, 3. 1, 2, 3, 4, 5. 1, 2, 3, right there. And if I connect these together, lo and behold, what kind of a line does that look like? Well, not straight. They're all straight lines. It's horizontal, right? Okay, I'm not putting the arrows on here just due to time. Look, they all intersect 2, 3, but now this green one with a 0 slope looks like it should, doesn't it? Okay, it should be horizontal. We got one more to do. All right, let's do this one, the fourth one. So the slope of line 4. For the fourth time on this problem, we're going to find the slope. So it's the change in y. So 3 minus 5. Again, I could have gone 5 minus 3. It doesn't make any difference as long as you do the bottom one the same direction. This is 2 minus 2. Uh-oh. What happens? I get a -2 over what? 0. So what kind of slope is this? It's undefined. I'll just write that, okay? Which means it's going to be what kind of a slope? What kind of a line? We've seen a positive slope. We've seen a negative one. We've seen a 0 one. Now we have a vertical one, okay? And let's see if it actually looks like that. I don't know. Let's use, well, this purple. Let's use this pink one. See if that shows up. 2, 3. We already got that point right there. And then 2, 5. 1, 2. 1, 2, 3, 4, 5. So there's the 2 points, right? There's these 2 points right here. We just connect them, and they have the same x value. I'll just take it to there. That's good enough. There it is right there. So there's all our lines. They all intersect 2, 3 because they all had 2, 3 as the same point, but they all look different. We got a positive, we got a negative, we got a 0, we got an undefined. All right, so that should help you kind of visualize the difference of what these slopes look like. Okay, the red one goes up because it's positive. The blue one goes down because it's negative. The green one just is flat, okay, because it's a 0 slope, and the pink one goes up and down. It's completely vertical, and that's an undefined slope. All right, let's do one more example, and we will be finished. About time, huh? I know. I get tired of hearing myself talk too, believe me. Okay? I don't always enjoy it. So, and I got to hear myself all the time. All right, here we go. It says, this time we're going to draw a graph. Draw a graph. And it contains the point, I'm not going to write that down because of time. It contains the point 3, 2. We're going to draw two graphs. The first one, it says it has a slope of 3/4. The second one, it has a slope of -4/5. All right, and let's put our little graph here. We'll use that. It's just kind of nice. Yeah, about good enough. Let's make it bigger. Right there. Tell you what, let's slide this over. There you go, good enough. All right, so let's, tell you what, let's just do this. Let's make this red. All right, so what are we going to do? It says draw a graph that goes through the point 3, 2, and it has a slope of 3/4. We should be able to draw a graph with that. All right, so let's find the point 3, 2. 1, 2, 3, 1, 2. Goes through that point right there, and it has a slope of 3/4. Now, this is it's not tricky, but this is the part that's new. We have to, from this point right here, we want to find the slope of 3/4, which means we start at that point, and what do? We rise, and we what? Run. Okay? Christian, you getting all this? So we start from this point, and we rise 3, and we run 4. You could, if you wanted to, you could rise -3 and run -4. Wouldn't that give you the same line? Sure it would. But you got to start from this point. Let's rise 3. So what do? We go up 3. 1, 2, 3, and we go to the right 4. 1, 2, 3, 4. I could just stop right here and draw it if I wanted to. Or if I wanted to, I don't know why I would want to do this, but I could go -3, -4. So let's rise -3. 1, 2, 3. Run -4. 1, 2, 3, 4. They should all line up. Does it look like they line up? Absolutely. So it's going to look like that. I'll extend this one out a little bit like that. You could always put arrows on there. I'm not going to due to time. There's your graph. That's what you would do. That's what they're going to ask you to do. Okay? There's one. Let's just do this. Bell's going to ring, but hang on. Don't leave until I tell you to leave. Okay? So again, it goes through the point 3, 2, which is this point right here. All right? Let's. Thought I'd change it to green. Okay, so it goes through here, and the slope is -4/5. Now remember, don't pack up. What are you doing? Hey, don't pack up. So you've got -4/5, or you could write it as what? 4/5. Either way, you do it. You should get it. So let's do it. Let's rise -4. We go down 4. 1, 2, 3, 4. And we run +5. 1, 2, 3, 4, 5. Right there. Or we could have done what? We could rise +4. Let's go up 4. 1, 2, 3, 4. And we could run -5. 1, 2, 3, 4, 5. Do they line up? Yeah, they do. Just like that. Extend it out like that. And look at that. I am finished, and the bell hasn't even rung. All right, you know what your homework is. I don't know. Somebody have it in front of you? Who's got it in front of them?
Section 2, 3, part 1.
Page what? Page 1 something 5, right? What 185, 11 to 35 odds. All right. Just so I'm consistent. There you go.